Assalamu alaikum. Okay, children, we are going to continue our video with 19.2 electricity flowing through conductors. Right, when the electricity flowing through the conductor. First, you should know what is conductor. Right, they have been explained in your book. What is conductor? What does conductor mean? Conductor. Right. Now, think about sodium. Right. When normally, when that it's a conductor, it's a metal, right? Which has 2 electrons, 8 electrons, and 1 electron in the valence shell, right? Now, normally you have been learned in the chemistry, I think, right? Most probably you have been learned, right? And normally the sodium doesn't appear or doesn't be there in the nature with the atomic form, right? It always change its nature as ionized form, right? By removing this 1 electron, because removing 1 electron, it's very easy to sodium. Now, if you take a sodium structure, a piece of sodium, and if you zoom it inside or scan it inside, right? A sodium atom is going to be there with a positive nature, right? Sodium atom is going to be there. Right? By this sodium, right? 1 electron has been removed. Here 1 electron, here 1 electron, here 1 electron, electron, all going to leave 1 electron. And if you take a piece of sodium, there are going to be numerous atoms of sodium, right? All these atoms of sodium going to remove its valence shell electron and be in the stable condition, right? Then it's going to get the positive nature. Then the electron has been removed. Now, this electron is not bound with the sodium atom, right? It's very free. We are calling this as free electrons. Calling it as free electrons, right? Keep this in your mind. I'll just explain another thing, another idea to you to understand what is current electricity. Keep this in your mind. Now, we consider a place where some electrons are present. In other words, we can say some negative charge carriers are present, right? Or in other words, we can say negative charges are present. Not the electron, negative charges inside the electron is negative charges are there. That negative charges are present, right? We'll take it as something 6 or something, right? Here we'll take more than 6, more than 6. Now, if you are having some amount of charges in a place, right? There will be a physical nature for that place, which is known as potential. Right? You don't want to think about what is potential. Just keep this in your mind. Right? Here the potential is maintained by the negative charges. Here also the potential is maintained by the negative charges. Right? The amount of negative charges present here, it's going to make a potential value. By here the amount of electrons are present here, a potential value, it's going to be maintained in this place as well. But the potential value here is going to more than this place. The potential value is going to more, right? If the potential, the concentration of the electron by the potential of the concentration of the electrons, right? If the potential is high here, right? If you connect these two, right? From higher potential place to lower potential place, normally the charges are going to move. You know that the charges doesn't move alone, right? It cannot be moved alone, right? It always moves by the carriers of the charges, right? Here the carrier of the charges is electron, right? This electron is going to move from this place to this place, right? Like if there is a place where the pressure, the atmospheric pressure is high, and in another place which has atmospheric pressure low, right? By the pressure variation, right? The air which is there in the place where the pressure is high, right? From that place, right, to this place, the low pressure place, right? The air is going to move, right? Because of that only we are feeling the wind. The wind is going to be there because of this variation of the pressure, right? The same as, right, here it's not the variation of pressure, but we are calling this variation as potential, right? Because of the potential variation, this is going to try to move, right? If you continuously maintain the potential variation, then continuously it's going to move. Now you know the electron has a mass from your chemistry, right? The electron has a mass, right? If a mass substance is moving, meaning, right, there should be a force which is act on this electron by this potential variation, right? That force is known as electromotive force, right? We are calling it as EMF. EMF, right? Electromotive force, right? This electromotive force is going to be born because of the potential difference, right? By the potential difference, the electromotive force is going to be rising. Then because of the electromotive force, the electrons are going to move, right? But by moving the electron in a same direction, right? You can feel something is moving from this place to this place, from lower potential place to higher potential place, from this place to that place, right? That physical nature, that physical, but the feeling, right? By moving the electron one place to another place continuously, you can feel something is moving. Something, we don't know what is that. Something is moving in the opposite direction, right? Of the direction of electron, right? That thing has been found as electricity or current electricity. By the movement of the electron, we are feeling a current electricity in the opposite direction, right? That is known as right. That is a current electricity. Okay. Now come to this place. Now you are going to maintain this place, right, across this sodium, right? You are going to maintain this side as lower potential and this side as higher potential, right? If you are maintaining higher potential here and maintaining lower potential here, then the electromotive force is going to be act across the sodium piece in this direction. Then all the sodium going to get a force in this direction. How? You don't have to worry about it, right? Go to advanced level, you will learn this, right? These electrons are going to move in this direction, right? If the electrons are continuously moving in this direction, therefore the current we are not always symbolizing the current as I, right? The current is going to be in this direction, right? More potential area is because of the electron, right? We are calling it as negative side, right? Since this also a negative, but we are considering with this, right? This is low potential side. We are calling it as positive side. This is what we can see in the battery, In the battery, there is a positive side and a negative side. This negative side maintaining more electrons or more negative charges. This positive side is maintaining less but electrons or less charges, less negative charges, right? Therefore, if you connect a conductor across this, right, the electrons are going to move from negative to positive, right? The current is going to move from positive to negative. That's it. That is the current, right? That is the current. Now, if you think about a place something here, right? Now we'll take something in detail. Think about this. Now, here the potential is there. Now, if I increase the electron here, right, like wind, right, like in the case of wind, right, if more pressure is there in the place where we are considering more pressure, right, if the pressure is getting increased, then the speed of the wind also going to be increased, right? The same as if you increase the charges, then the potential is going to increase, right? Then the potential different, because of the different only the electron has been moved in this side, toward this side, right? By increasing the potential here, right, the potential different is going to get different. Normally the potential is measured in volt, right? We are using the unit volt. I am saying here you have 2 volts. Here you have 5 volts. Now what is the potential different? 3 volts. Because of the potential different, the electron is moving, right? There is an influence of these 3 volt of in the moving of electron. For an example, if you increase the potential here as 10 volts, right, then the potential difference is going to get 8 volts, right? Because of this potential difference, the movement of this can be seen in the movement of the electron. The electron is going to move very quickly. By moving very quickly, we can get very rapid movement of current as well, right? Therefore, the current, the value of the current is going to get high, right? Then the current has a proportional relationship with the potential difference, right? The potential difference. If you take, I'll say this B as not this volt, this is not the symbol, right? I'll take this B as the potential difference. If you think about the potential different V, right, it's proportional to the current. If you increase the potential different, you can directly increase the current. Okay. Now to equate this equation, right, we can put a constant here to multiply this, right? This is proportional sign. If you want to change the proportional sign and it's equal sign, you have to multiply by a constant this current, right? That is the mathematics. Don't worry about it, right? This constant has been known as the resistance of the substance that we are using, right? The substance that we are using to move this electron, right? It can be a conductor, it can be a resistor, and everything, right? The resistance is going to be the constant, right? Don't think about the deeper, right? Because it's not there in your syllabus, right? In your syllabus, it's very easily explained, very normally explained, right? It's not deep, it's not there in great detail, right? Don't worry about it. This relationship has been found by a scientist who is Ohm, right? We are calling this law as Ohm's law, right? This relationship is applicable when the temperature where we are doing this, the temperature that we are doing this, right, get constant on. Right, you have to keep the constant the temperature as constant to do this. Right, the Ohm's law is applicable when the temperature is constant. Right, then once you start your the Ohm's law to tell the Ohm's law, you have to start with the when the temperature is constant. Right, the potential difference is proportional to the current flow in the conductor. Right, this is potential different. Keep this in your mind. This is potential different, not the potential. Potential different is proportional to the current flow. Okay, that is the 19.2 that you have. But if you go through your book, right, you can see that in the 19.2 and the 19.3 I have been completed. Right, electromotive force and the current electricity in this video. And 19.4 is the relationship between the current flowing through a conductor and the potential difference across the conductor. That also has been completed. The Ohm's law, I completed this as well. Right? Okay. Until 19.4, I have been completed by giving this explanation. Now, another thing that you have to find, you have to know, we have 2 meters, right? 1 meter, 2 meters mean 2 measuring instruments, 2 meters. 1 meter is known as ammeter, right? Another meter, which is known as voltmeter, right? The symbol of voltmeter is V, like it will be denoted in a circuit like this, right? This is going to be the current, the measuring meter, which is ammeter, right? The ammeter is going to measure the current. Because of that, we have to always connect with the conductor directly to measure it. Right? Always we have to connect to the conductor to measure it. Right? There is another meter that we are using to measure the current electricity, the current, how much of the current is flowing. That is galvanometer. Right? The difference between the ammeter and the galvanometer. Normally, ammeter, in the ammeter, the zero is starting from here and the calibrations are going to be like this. Right? Then from the zero, it's going to show you how much of current has been flowed. Right? If the current is flowing in this direction, then you have to connect the zero in this direction. Then only the current, how much of current has been moved, can be seen. Right? If you change the terminal of ammeter, you can't measure the current. Okay, right? But in the galvanometer, the zero is going to be in the middle, at the middle, right? In the either sides, the calibrations are going to be there, right? Therefore, if the current is moving in this direction, the needle is going to show you in this side. And if the current is moving in this direction, then the needle is going to show you this side. Then both the sides, the current can be measured using a galvanometer, right? Both are measuring the current, but the use of the both are different. Right? Since this should be connect directly to the conductor, right? Directly where the current is flowing. We are calling this as, right, this connection as series connection. Series connection means it should be connected series. If you consider a very small circuit like this, right? This is the indication or the symbol of battery, right? This side, the long line is positive, the short line is going to be negative. This is a battery, right? This has been learned in your earlier grades, right? Now, I'm going to connect a bulb here. This is a symbol of bulb, right? Now, the current is going to flow through this wire to the bulb, right? It's going to complete in this side. Okay. If you want to really control this, you can put a switch here. If you close the switch, current will flow. If If you open the switch, current won't flow because the conductor is disconnected, right? This is the symbol of switch, right? Like this, symbol of switch. If you close it, current flows. If you open it, current won't flow, right? Now we are closing that switch, right? The current is going to move. Now if you want to measure the current, what you have to do? You have to connect the ammeter in the in the circuit in this manner, right? We are calling this connection as series connection. Now you know, if the current is moving in this direction, right? If you consider these 2 points, there should be a potential variation, right? There should be a potential variation to make a flow of electron in this direction. Then only the current is going to flow in this direction, right? Then the electron is going to flow in this direction. The current is going to flow in this direction. Okay, you got it, I think. Okay, right? Then if you consider the potential here, it's going to be differ from this place. Then how much of potential difference is there? If you want to measure it, then you have to connect the voltmeter one terminal to this point and another terminal to this point, and the connection should be like this. Then only the voltmeter is going to show you the potential difference between these 2 points, right? Normally the potential difference is measured, right, not through the conductor, but it should be measured, right, by connecting 2 places, right, with the voltmeter, and we have to measure it. Okay, this type of connection is known as parallel connection. It's like parallel. We are calling this as parallel connection, right? Then the ammeter is connected seriously with the circuit. Voltmeter will be connected parallelly to the circuit. Then if in a question, right, this has been given as X and this has been given as Y. If they ask you to write what is X and what is Y, then you have to say this is ammeter, this is voltmeter. Use of voltmeter is measuring the potential difference. Use of ammeter is measuring the current flow. Right? Then that's it. Until your 19.4, right? The final part. No, 2 more parts are there, which is resistance. It's about resistors and the resistance, but we'll see that in the next video, right? Jazakallah.